Good afternoon, everyone. I will present nanomaterials for stealth and counter-stealth technology. Before that, whatever we are studying in the stealth and counter-stealth, all the related to electromagnetic field, and second is the materials. If we understand what the two things, so we can design the stealth technology and also counter the stealth technology. So here I first I start with the engineering electromagnetic signature for aerospace system. So here the four system is there, how the stealth is there, and how stealth system can detect, and how we can infuse the AI system to track the data and again counter the stealth technology. And for that, we use mostly, here I mentioned the four materials, graphene, MXenes, ferrite, dielectric, hybrid. This is just example. We can change the graphene. Graphene is electrical conducting, and electrical conducting, why? Because it has a free surface charge, and like MXene also has a free surface charge, 2D materials, 2D nanomaterials. Ferrite is the magnetic property, and dielectric like is help to create the nanodielectrics in the polymer system. So these are all the property used to design the stealth and counter-stealth technology. I will go ahead. So what the modern warfare? We have seen the Israel and Iran and Russia, US war, because Iran is ahead of the US and Israel, I can say, because Iran is using the counter-stealth technology and stealth technology to counter the USA. Because all the air defense system of the USA is not countering the ballistic missile of Iran. And Iran is hitting hard. So I will explain a little bit how this is happening. So here is how our system is evolving, and how the threat is evolving, and how the materials and system is countering that system. So fourth, the next slide is the technology shift from the stealth to counter-stealth technology. First, when the 1990, the stealth design was based on the conventional material. That materials depend on mostly the single band structure. As I mentioned, whatever the mention in the stealth technology, all the related to the electromagnetic and how the materials respond to the electromagnetic field. So now currently, only conventional stealth technology is not working in the market. They have used the other parts of this system, like plasma, structure variation, RC value, because we know in F-35 fighter jet, RC value is very low, like 0.001 at the center, but in the wings and rear, the RC value is very high. That is the drawback of the F-35. If we counter this different angle and different polarization of electromagnetic, then we can capture where the F-35 is flying. But mostly we set the static radar system, like Marine and something. That is the particular angle, and that hit the stealth front, and that RC value is the counter by the 0.001. So now I will tell how this we can counter and what the drawback of the stealth technology. So that's why Iran is dominating the USA. Third, this is limitation of stealth. Stealth is limiting by the three things. First is the band, because whatever we design the materials, that materials respond. Conventional materials, I'm not talking about nanomaterials, I'm not switching the nanomaterials, I'm just currently conventional materials has a specific band response, means like gigahertz, tetrahertz, IR, and whatever electromagnetic field, electromagnetic frequency range there, that conventional material response is the particular band. So whatever we designed earlier, the stealth technology, that was the specific materials, conventional material, which responds the specific frequency range. But when technology evolution happening, they started to change the materials and structure design. So what happens? So these materials can respond to the different band and different electromagnetic angle. So here I am mentioning what the things. First is the optimized band. When we are designing the stealth technology, a counter stealth technology, we have to focus on the two things. First thing, optimized band. Which band gap this materials of the aircraft is covering. Second is this thickness dependent. This is the one equation called quadratic wave condition. Means if a electromagnetics hitting the aircraft, if destructive interference happen at the interface, we cannot get any signal to the radar. So we cannot analyze where the stealth aircraft is moving. So that is the thickness dependent limitation. Third is the angle dependent limitation. Because I mentioned the front is the RC value is lower, but left and right and rear has the RC value is high. So if we change the angle, we can get the position and other things of the stealth aircraft. Next is the material property. When we are designing stealth, that material should be dielectrics, magnetics, and also insulating. And also they have a very good weather, like corrosive and weather response, like corrosive resistance and something like that one. Next. So here, this is the how the electromagnetic, we know we have a two component. So most of the case we forget to only we are like previously they mentioned we are using the graphene. Graphene is electrical conducting, CNT is electrical conducting. Electrical conducting materials has a free surface charge. They can reflect. They can only react with the electrical component of the magnetic electromagnetic field. But we have to suppress both electromagnetic fields. So we need to have a material that respond to the magnetic field. Then next was the radar cross section. So we can change the different radar cross section and we can absorb where the positioning. Third is the how the materials respond the electromagnetic, like three mechanisms mostly happen: absorption, reflection, and internal scattering and transmission. Mostly insulator we have like the transmission, conducting reflection, dielectrics and electrical materials mixed together form a nanodielectric which can absorb and dissipate in the form of the heat. So these are the most four equations. Last two equations mostly used for the stealth and counter-stealth technology. That is the Faraday law and Maxwell-Faraday law. These are the like God for this stealth and counter-stealth technology, because change in electrical field can convert in the produce the magnetic field, and change in the magnetic field produce the electrical field. So if we are not playing with the both field, definitely there would be signal of the either electric field or magnetic field. So that is the four things. Last two equation is most important. Then impedance matching. If we want to have a very good absorbing material, so that material should have a very good surface impedance matching. Impedance matching means resistance, means impedance matching should not be much difference, otherwise reflection occur. If reflection occur, then radar can capture the signals and detect where this aircraft is there. So impedance matching is very good for the absorption materials. And then this is how the multi-physics, because radar sensing, infrared sensing, plasma and structure. These are the four combined sensing method which using the Iran. Because Iran is using ballistic missile. What happened with why that USA air defense system not countering was not able to counter some of the Iranian missile? Because when the ballistic missile enter the air atmosphere, that create a plasma around the missiles. And that plasma can deflect the electromagnetic, because we sense anything by the electromagnetic field. So when this electromagnetic field hit the plasma, that plasma either scattered, either absorbed, or deflect. So when we use the squeezer, means a artificial magnetic field on the rocket system, that magnetic field can control the thickness of the plasma. So that I mentioned quaternary wave condition. So means specific a thickness of the plasma can destructive interference of the electromagnetic, and that destructive interference can cancel out all the radar signals coming to detect, and that cannot detect where the missiles is coming from. So like 100% surety is not there detection, but at least 60 to 65% is the probability to achieve the goal of the missile, because of this plasma and the squeezer that control the thickness of the plasma around the missiles. So in the future void, only radar system will not able to control the air defense system. We need to have a infrared sensing, plasma and other sensing, structure sensing to counter the stealth technology. If we only depends on the only radar system, so we definitely the game is over, because technology is changing and they are using the different, because Russia and China already prepare that missile which can create a plasma, a specific nano range plasma around the ballistic missile. So in this case, radar system is not useful because that plasma counter the radar system signal. So next. So for the, why the nanomaterials important? Because this nanomaterials has a high surface area, tunable materials property, broadband performance means not narrow, broadband means here, because we are creating a hybrid material which can perform a very big like megahertz to gigahertz frequency range, a tetrahertz frequency range, like that one. So we can, if someone is changing the different frequency range radar signal, so that materials can control that radar signal. If we are just creating a material which has a only megahertz radar frequency range, then and suddenly we switch to the tetrahertz frequency range, so our system can detect it by the tetrahertz frequency range. So in the nanomaterials, we can change, increase the band of the suppressing the radar signal. So that's the thing. Now what are the materials we, I will skip because time. Here, so what are the, how this stealth layers prepare? Like we have a many layers. So first of the like protective layer which can protect the corrosion and other things. That is the, then we have a top coated dielectrics layer which can absorb the, this dielectrics is not normal dielectrics, that is the nanodielectrics. I have included some result. This is not normal dielectric, like ceramic materials included in the polymer matrix and created dielectric. That is not, that is nanodielectric. Means like polymer and like we know the two metal sheet and one insulating is the dielectric. But when the two like carbon nanotube they mention and in between carbon nanotube, polymer chain is the inserting. So that create the nanodielectrics. So this type of advanced materials used for the dielectrics, and then the layer magnetic like ferrite and something like spinel like cobalt and other high performance alloy we can use. And sometimes we use the nuclear grade high performance ceramic material to improve the performance, and then aircraft structure. That is the layer how to they design. But only materials is not contributing the stealth performance. Also the design, how they design the structure and angle and other things also is helping to the design the stealth technology. Next. I will go. So how to counter? If we switching the frequency, different frequency, switching the radar, and polarization means if like electromagnetic field is changing the sudden like 1,000, I have performed, this is my work, what I am doing currently. So I perform like 1,000 cycles per second, and that can counter the stealth technology. If suddenly we switching the cycles 1,000 cycles per second, yeah, 100 cycles per second electromagnetic like frequency range, so stealth is like something failed to suppress that frequency range. And then I already mentioned multi-physics radar sensing to by like infrared and other plasma and other radar system we can use to improve, counter the stealth technology. Like multi-band radar like X-band, Q-band, and polarization radar, passive radar, like we also use the passive radars inbuilt, means like we have a static radar system, airborne radar system, and in between passive radar system and multi-static radar system. Like so, like a system like a stealth aircraft in between room, and all the radar system covered by the wall of the room. So same like we can generate. So there is no chance to hide anything. I'm not only talking about stealth. I'm talking a stealth type missile system, all the things. Only I'm not covering the aircraft. This is the applicable for all type of stealth technology, whatever the using Russia and China, even currently using by the Iran. one more thing is there, why the Iran drone system is more useful and they're destroying the USA? Because they are using the AI-based system. Because if we are sending, one more factor, Iran-Israel war is the EN factor, efficiency factor. Efficiency factor means how much we resources putting in the system or how much we are getting output. USA using the THA and other missile system that like millions of dollars. And like Iran using $20,000 unmanned vehicles. So if Iran is sustainable to run this one missile cost, Iran can fight the like 2 to 3 days. So that is the same thing. That how to discount this cost effective and AI fusion system means like if like one unmanned vehicle going to the territory and that's shut down. So whatever, all the network of the UV unmanned vehicles connected to each other, and they can transfer the AI data, where the missiles and where the air defense system is hitting them, or they can just share the data, and that data can because AI is not like thinking like that. They find a certain type of the pattern, and that pattern they analyze and give a data how to the output data is coming. So like that, they can give a short time of data where the defense system there and how we can change the our trajectory path. So just like one is going like straight path, and they are finding like the AI system detected this path is not dangerous for the unmanned vehicle, so they can suddenly change the track and path of like one bullet is moving like a snack, and other bullet is coming straight to hitting that one. So it's very difficult to hitting a straight bullet to the moving bullet. So same like system. So this system is achieved by the AI fusion system, where they gather the data and process the data and implement that one. So this is the AI fusion. I will skip because. So AI fusion system is lot of things is there like filter data, gather the data means like if they are using the 20,000 like drone, that's shot down. But they are using those data that already shot down, but that drone is not useless because that drone already gathered the data, projectile and trajectory of the upcoming missiles and others geographical scenario. That data sent to the others command center. A command center analyze the fuse response and process the data and analyze how to the we can drive the others unmanned vehicle and something like. So this is the fuse process response system, and this is
Dr. Raghvendra. We will limit it.
Just finish. Okay. Yeah. So this is the experimental validation. So here I developed the MXenes based material. Here, second, whatever I use the nano dielectric. Mostly everyone know here, when we putting the nanomaterials in the polymer composite, TG always increase, but here TG is decreasing. That interesting thing. So that is created by nano dielectrics. Then third is the EMI shielding I measure. That is the thickness varies in EMI shielding. And that I have one video. Here I track the nanomaterials, how the nanomaterial moving in the system. So here dynamics I study. Here I snapshot the dynamics of the system. Here I develop the graphene system, already new materials. In India, I developed, first person who developed the graphene. And I send this graphene to the Stanford. So they process that. Then here I develop some materials, because here you can see the spherical thing. A sticky like fiber like structure I developed with the help of the nanomaterials. Here fibers and also selective localization of nanomaterials and system. And you can see EMI shielding I improve. And here real permittivity and other property, whatever nanomaterials use for the EMI shielding stealth technology. So here the MWS is the Maxwell-Wagner-Seeler effect, mostly important for the stealth and polarization effect. And this is the future research, whatever I am doing. This is all the PPT related to my research work, whatever currently I'm doing, and I extracted little data from there and explain here. This is the sorry. This is my future work, what I'm going to do in the next couple of months, and thank you.